In this video, I'm going to go through question 3 from the Vector Addition and Components homework for my HS Physics course. So in the corner of the screen, you can see what the question was. A car drives 35 kilometers, and then in square brackets, we have north, 60, east. Okay, so the square brackets indicate that this is a direction, and I'm going to look to north. Let me just draw a little bit of north-south dotted lines here. So I'm going to look to north first and then 60 degrees to the east. So that's north first and then 60 degrees to the east. So let me just sketch that in. Let's say it's going to be right here. Now, what we're asked to do is to find the components in each direction, first north and then east. Okay, so if we look at the 60 degrees here, and north is this one right here, notice that north is adjacent to the angle that we're talking about. That means I'm going to be using cos. The length of the hypotenuse is the 35 kilometers. So if I write this out, cos 60 will be the adjacent side. I'm going to use an n for north, over the hypotenuse, which is 35. Now, if I move that around, I'm going to get n 35 cos 60, pick up my calculator, and I'm going to get 17.5. So now let's think about doing the east direction. So now we're looking here. Okay? There's a couple ways we can think about it. We can either say, hey, this angle right here, that's going to be 30 because north and east are perpendicular. And then my horizontal direction will be adjacent to 30 degrees. And now I can do cos 30 equals, and we're going to use E for east, over 35. Move that around, and I will get 35 cos 30 equaling 30.3. Another way you could do this with that 60 degrees is to say, all right, my east component right here is going to be the exact same length as this part right here. And compared to my 60 degrees, that side will be opposite. So what I could do then is say opposite and hypotenuse, that's sine. So I could be saying sine 60 is going to be the east side over 35. And when I move that around, 35 sine 60, put that in your calculator and you're going to get 30.3 as well. Okay, so let's go through B then. It says 60 kilometers south, 30 degrees east. So let me do my little scales here. I'm going to look first to south and then 30 degrees to the east. That will make my line about here. Okay, so now if I want the south component, that means it's going to be this side here if I break it into components. That is going to be adjacent to that 30 degrees. So we're going to go adjacent. That's cos, right? Cos 30 is going to be the adjacent side. I'm going to call S for south, over the magnitude of that vector, which in this case is now 60. So south will be 60 cos 30. And you put that in your calculator and you're going to get 30. So remember, there's a couple of ways I can do the next one. If that's south, the other component, east, is going to be sine 30, because now we're looking at, instead of the adjacent side, we're going to be looking at the opposite side. So I can go and say, okay, sine 30 is going to be east 60 and you put that in your calculator and we get 52. kilometers per distance. Okay, so now let's put, for part C, let's put them all together. Okay, so this is what we've got so far. The first distance ended up going 17.5 north and then east 30.3. The second distance we went south 30 and then east 52. So let's think about the first one, north and south. If I think of north as being positive, plus VE, remember that's the sign for positive, then I went 17.5, and then I'm going to have to say I went down 30, and I'll use the negative sign there to show that it's in the opposite direction, negative being south. And when I do this, I'm going to get negative 12.5, saying that my net movement is 12.5 in the south direction. And in the east-west direction, I went east both times. So I'm just going to add those together. So now that means when I put my two vectors together, I have a south direction of 12.5 and an east component of 82.3. So now we need to put this information together, and so we have our components, and now we need to get the resultant. So the resultant is going to be, if I added these two, and it would be the diagonal right here of this rectangle. Okay, so how do I get the length of that rectangle? We're just using Pythagoras. So 12.5 squared plus 82.3 squared, and get the square root of it. So there it is. When I put up my calculator, I'm going to get 83.2. Now I'm going to need an angle because this is a vector. So I'm going to put my theta right here so you can see I'm talking about south and how many degrees to the east. When I've done this, now compared to my theta, this is going to be my adjacent side. And I also know the length of this side, my opposite, is going to be 82.3. So what trigonometry function has opposite and adjacent? That's tan. So here we have tan theta with my opposite over the adjacent. I'm going to put that in my calculator, and remember we're going to need to tan inverse or arctan both sides. And when I do this, I'm going to get 81.4 degrees. So if I want to write this in proper notation, that means I'm talking about south, 81 degrees to the east. Hope that helps you solve these problems. We had two different vectors that we added together, and we added them by breaking them into components. Once we added the components together, then we had to go back and take those two components to create the resultant one more time.